Well, holy shit! Here we go. Okay. I
On
don't
that
actually.
note.
Yeah, we got to swear to start with. Yeah. So slightly different setup this time. Slightly different setup. We've got Vijay out on urgent business, so swooping in to replace him. Well, or to at least fill the co-host gap is Wouter. Hello,
Yes.
Wouter.
Hey, so we ran the idea of basically transcribing whatever I say and then running it through a voice synth with Vijay's voice. Because I mean, by this point, like which episode number is this? Like we're running up to 90, like 88, 89, I don't know.
Somewhere around that number, yeah.
Like that surely that's enough of audio to train an algorithm to reproduce Vijay's voice, no?
I think so. Yeah,
might actually just be fun to do. Actually, just see if we can replace that.
But the good thing is that we haven't just got me and Wouter. That we have got a guest as well, which is always a treat and always good to have on Deafin. So, hello, Kimmo. Hello, Kimmo. By the way, I say Kimmo, but I'm thinking it might be Kimmo or something like that. It might be a particular thing that I don't get.
Yeah, you actually got it pretty well there. Kimmo. Kimmo is the I guess Finnish word.
Kimmo.
Yeah, Kimmo.
Yeah. And So and but you've got a Koskinen. Is it Kimmo Koskinen? Or Kimmo Koskinen?
Koskinen.
Ooh.
Koskinen. Koskinen.
Nice.
So, Alex, we also want to apologize for not getting the Eurovision victory you so deserved.
Yeah.
I'm pretty sure it was set up, man. Like,
yeah, we were actually with my wife watching the Eurovision. Well, not that late, but the Finnish performance and so on. Here in the same the terrace that I have here. I don't know.
Oh wow.
So it's like but yeah, it was. I guess I guess I have to say that the who won it, they have like a good good thing going on there, but but it was Käärijä did a good try. The jury wasn't so easy to please, I guess.
No, but like because Visa was talking about with my brother about it, and essentially Finland got so many votes from the popular vote that every country must have given at least 10 points to Finland. So in order to get like 380 whatever, so like Finland almost scored like the maximum of points you could get with the popular vote. So it kind of, I mean, it feels a bit set up, with like 50 years after ABBA, it goes back to Sweden, like, but whatever. Anyway, I truly enjoyed the act. It was everything I wanted out of a Eurovision song act, like way over the top, totally aware that it's way over the top. It was
also like it kind of been like nice because you're very friendly with Sweden, so that's all good, isn't it?
Yeah, there's this interesting awkward friendliness going on. But so it was so I just hope that the guy Jere who was like performing that he doesn't like feel so bad about it, because he was really he got like people to move and to like got excited, and but he was also like saying that hey, it's just like okay, that we didn't get to please the jury, but at least we tried. So that was a good song.
So I guess it's kind of like, maybe it's obvious now that you're from Finland, but maybe it's not. But so just to nail it, you're from Finland and you're in Finland right now.
Yeah, true. I'm from Finland. I'm like southern Finland. I live in Espoo, so like in the woods. So like people here live indoors, like you saw.
But well, the people on the podcast can't see, but you pointed the camera around and you were literally in the woods.
Yeah, well, it's like 20 kilometers by like line of sight to Helsinki center, where I live.
That's not too bad.
Yeah, it's not too much, but like well, when doing commuting, it's like takes me an hour to go to the center.
Yeah.
But so I kind of
That's
like
not
the
a
place
Finland
where I live.
exclusive. I live 20 kilometers away from Antwerp in Belgium, and if I get there in an hour by car, it's a good day.
Yeah. And I think, but I guess nowadays, Kimmo, it's kind of Kimmo. It's all kind of remote work now. So you're remote in the woods, or do you still pop into the real office sometimes?
Yeah, sometimes. It's I kind of like well, for me when the corona stuff started, so having 2 kids and then skipping the like commute to drive the kids to the daycare and then get out of the daycare. This remote work was like actually a good thing. So, but yeah, should probably visit the office maybe a bit more. But like the times that I go to the office, then they are more cherished. So we usually have something going on, some kind of maybe it's project kind of meeting thing or just like whole company meeting thing. So and so the office, like we have. So I work for Metosin.
Who are they?
And yeah, that is funny Finns who make funny libraries who are hard to pronounce. So the names of the libraries that are hard to pronounce. Well, actually, I don't know. I have to link the. We just went to the. There was the cons. And Mikko did a recording of how to pronounce rated and Malli. I have to find the Twitter link to, to that pronunciation thing. But yeah.
I think it's all the other ones though. I can't remember. There was one beginning with S, Serapue or something. I can't remember what it is.
That's that Sieppari. That's.
Oh yeah, come on. I mean that's but I mean I've forgotten what it does now, but I know it's hard to pronounce.
Yeah, it's an interceptor kind of library, but yeah.
The
name is probably a bit hard.
Yeah, it's a bit harder than rated. Yeah.
Yeah.
But okay, so what are you doing over there at Metosin or Metosin?
Yeah, I'm doing project work mainly currently. So we have like couple of we're a small company, but a couple of clients and then we try to also maintain those libraries that we have. Also alongside. But yeah, it's this this Metosin is actually originally from Tampere, and so we have offices in Helsinki, but now we have office also in Oulu, like northern Finland, and Jyväskylä, which is like somewhere in the middle of Tampere and Oulu. So I was just like remembering like going to the office, so like being specific which office. So like the Helsinki office is the nearest office.
But Metosin are very famous for their Clojure conferences in the past, pre-pandemic. And I went to one in 2019, I think.
Yeah.
Can it be that long ago? No. Can't it be?
Probably.
Maybe it's 21. It was the last one before it stopped for a while, or at least before it was put on hiatus, let's say.
Yeah, true. I remember.
When was that? Was that 20 or 21?
2019. I remember.
It was 2019. Yeah. Okay.
Yeah. But yeah. So yeah. Let's see when there would be. I don't know. I should have to check like the marketing guys and if I don't like, say anything stupid. But
yeah. Don't worry. Yeah.
But really nice times. But yeah, so it's been after the like pandemic hit and kind of rough to restart everything.
Yeah, definitely.
Yeah.
I mean, it was famous for its kind of parties and great talks and great parties. So I was really pleased to have at least hit one. But I didn't actually hit the sauna because it was a bit like, I think Tommy asked me to go to the sauna about 2 o'clock in the morning, and I was like, easy, mate, it's a Me Too moment, Not really. It was all very fun. But 2 o'clock was too late for me. But is it like this where when you get your office get-togethers, so you basically just all hitting the sauna together and like sweating it out?
Yeah, it depends. But if there's an opportunity, just was it last week or so, we had a kind of company thing where we went to have a dinner. There's this island near the like Finnish coastal area, and there's a sauna there. So so you had dinner and then sauna, and then of course you get to go to the sea, like dip into the cold sea,
nice,
and then back to the sauna and again.
Wow.
Yeah. So I like so this podcast recording thing, like it's like 9:30 here. My kids are sleeping. I was thinking that, like, okay, what's the most quiet room that I don't bother the others? So that would be the sauna. But like doing the podcast from sauna, maybe.
That would be on brand.
It's the most Finnish thing to do. Because I was gonna say, because you were saying like, there's this place with the sauna, and like that's probably the most vague location specifier you can imagine in Finland. With a close second to, it's the hut next to the lake.
True.
Yeah. So you've been working with Clojure for a few minutes now, Kimmo, and so we usually start off here with a little bit of like a backstory on how you like came up to Clojure and what your route was to finding the light. Which darkness, which particular mushrooms were you eating before you arrived to the surface of Plato's cave?
How did you discover the parentheses?
Yeah, I kind of wonder that have to like always try to grow those mushrooms to like rediscover new things, but like maintain the art. But yeah, I guess it's been a while back. I think I remember when I bumped into Clojure. It was somewhere around 2009 is first time. I was in a product company startup called Ekahau, and it was either me or one other guy in the company, which we kind of bumped into that language. And it was the company was making a Wi-Fi planning tool and an indoor Wi-Fi positioning system. So my colleague there, which I learned quite a lot from him. It was like after the 2008 economic downturn thing, we got our first big layoffs in the company and so on. So my colleague jumped to another team, and he started a project, a rewrite of this application, and he started the backend with Clojure on 2009. And
that's very early days, no?
Yeah, it was really early days. The front end was in Flex, so like before this HTML5 era, Flex was like we were. So like I was like, hey, cool, but I was left as like maintaining in the team that kind of vanished around. Like a lot of people left, but so I had this like Java code base, 200,000 lines, something. I was like, I can't ever put a new language here. So, but anyway, I had a good time. The thing that I was making there was actually like putting money into the company, and it was great. And so I kind of looked like it has to be statically typed. So I kind of looked this Scala and Haskell things.
Okay,
sure.
So so like a couple of years did that, and then kind of circled back around 2012 or so, and started to like look more into Clojure, and switched team in 2013, and I don't know, 2013, 14. I guess I've been trying to mainly do Clojure. I switched to another company to a Finnish consultancy called Solita. Yeah.
Just before we finish that point, so you said you looked at Haskell and Scala, or did you look at it and did you introduce it like into the company, or was it just a kind of like fetish at that time, let's say?
Yeah, so it was this 2010, my firstborn. So I remember reading Learn Your Haskell like while being on parental leave and so on, and I kind of tried putting Scala into the app, but it's I don't know, the compilation times at 10. and it was just like just so much of a chore. So it was like mainly me, but the Clojure app that was like they were doing kind of good. They had like a thing going on there. The team was growing and stuff was happening, and so I kind of eventually that there has to be a kind of reboot of the thing, and then I kind of jumped the team, and it's so hard to like I don't know if you're in a situation in a team and you have like a product going on and you would want to try out something different. It's like if there's other people and if there's time and space, but if there's only you kind of hit into walls. And
you're essentially just spending time on upkeep, right? Like there's no time for experimentation, and every experiment is too risky because
there's always time for like some experiments that kind of go in the like general direction of where the kind of product is also going, and those are just easier to do and like fun and so on. But then if you have a bigger thing like changing a language, that's
you might get a lot of benefit from it, but you're going to have to spend a lot of time down basically, and nobody wants that. especially when your product is making money for a company. Nobody wants to stop and sort of make it faster for the developers. It's like, I understand your point, but no. I've heard some good things about Kotlin, though. I mean, in that sense, that you can introduce it relatively easily, and it sort of sits in the tool chain quite easily, and it obviously will like dry up, reduce the amount of code you have to write, but it plays very nicely as a sort of, I think, what Scala wanted to be, which was what Martin Odersky have sort of tried to sell it as, which was a better Java. Whereas Kotlin, I think, really genuinely is a better Java. And of course, people are getting used to it now with it being an Android Android default language.
I used it a bit when doing some stuff on when I still maintained an Android library, and that's how I thought about it. Like it's just like generally a better Java, but like Java has grown a lot of features in the meantime that close the gap. But I think that the main draw of it is because you can have a project, like you can have your classes written as a Java class or a Kotlin class. Like you can have both files in the same project. There's nothing really special to configure. The interop is entirely seamless. So it's easy to just try it out, right? You could be like, hey, I'll add this data class and I'll try it in Kotlin and I'll add a few methods and
I I think things like Scala and Clojure are definitely, like you're really changing the language, you're changing the concepts almost. Whereas with some of these like small improvements, like I know people who did things in projects with Groovy, for example, as well. Like you can embed Groovy in Java projects quite easily, So there's definitely scope even on sort of Java projects to have other languages working in it, but it really has to be like super smooth. It has to be like super compatible.
I remember when I was joining the company, it was 2005, and it was in the midst of a rewrite, second or third. But they weren't like changing the language though, so it was still Java, but like actually rewriting stuff. But maybe something like if you hit in a phase like that, then like well, okay, people have to like weigh things like and well, I don't know. Clojure has nice Java interrupt, and I remember later on bumping to the guys who were like still working at the company, and in some Clojure conference, maybe in Bratislava, I forget, but they got to like replace, tried out replacing like core parts of the Java thing with Clojure, so like emitting the interfaces and stuff. So like, but yeah, I guess the overall thing is that it changes quite a bit because, well, for me, like the Java that I wrote back then, it was really awkward, like all static functions and and trying to emulate this like functional kind of style. So it was kind of natural to like I don't have to like try to hide this thing.
Your true character.
Actually, having first class functions actually, you know, made the world saner, I guess.
Yeah. I guess Java has like come some way. Yeah, I remember the times it was like I don't know, the Sun and Oracle and that, and the language kind of stagnating. Now there's more and more things.
Like because you were saying 2005, like that's still peak Java, right? Like that's still where Java was like the one language that's going to rule everything, and like Java 1.34 maybe around that time.
Yeah, 1.5 was, I guess, just about.
Yeah. So I guess it was. It feels to me, I mean, at least in my recollection, it feels like it's only like around 2009, 2010 that like all the like there's a lot of steam behind the alternative JVM languages, right? Where I think like 2005 still feels like Java was the thing and object orientation was the thing.
The funny thing to me is that what I remember from that sort of period, like pre-2010, was that there was a bunch of like Lambda proposals for Java because everyone kind of realized that first-class functions, as you say, Wouter, was the thing. And there were like, I think there was like 3 proposals in front of like the Java language committees. I can't remember the details of them, but there was at least 3, and that had relatively broad support. But in the end, they just decided to do nothing about it. And then they had the Oracle buyout and all these other things. So I think that stalled a lot of innovation in the Java world until all the dust settled around Oracle's ownership and what they're going to do with it and all these kind of things and how the team settled out. But yeah, so all those potential innovations that would have came before Scala and Clojure around first-class functions just kind of fizzled out. And then it was, quite late, wasn't it? It's like, I don't know. It's way past 2010 that they got like Java 1.8. I can't remember what the exact timeline is, but it's certainly like way after like Scala and Clojure got their start.
Yeah. I haven't looked like what does modern Java look like, but probably you can do lots of stuff now. But I remember the like the kind of fear of stagnation that where is this going, this language? But it was but I guess the kind of JVM itself, it kind of just that just floated a bit more up, and like Clojure and Scala and Groovy and like a lot of options that hey, there is this actually this VM that is actually really good. So
yeah.
JRuby and there was quite a lot of big languages that were sort of coming to the JVM that weren't Java. I think JRuby was the one I remember being the first big one. Where it was like, oh, they're running this Ruby thing on here, and it turns out that it was faster in many ways than the native version of Ruby for certain tasks, anyway.
Yeah, eventually, even Python implementations, no?
Yeah, there was this. Okay, yeah.
Yes, JPython,
yeah.
Because I remember. Jython was it called?
Jython, yeah. There was, I don't know if that's still around. Wow. Hey.
Yeah. But I remember working for also like a consultancy company at a time where we had a customer whose requirement was that everything needed to run as a WebLogic application container. And we were made aware quite late of this requirement in the development cycle. And so I remember having done a few really unholy things to port Python code, Ruby code, Common Lisp, actually, to run inside of a container. It started when we delivered the project, but I won't vouch for anything more.
Okay. Oh.
Right. So we're kind of we got to Clojure. No, it's good. It's good. So we got to Clojure. We've been a lot of reminiscing going on here today. Right. So maybe we should have a quick catch up as to what we kind of started talking about, Kimmo, to motivate you to come onto the show, and to give some background about why we started talking on the Clojure and Slack about performance of lambdas and Clojure in lambdas. So maybe you're in a good place to sort of give a bit of background on that.
So Ray puts out some message in Clojure Slack, and then I reply in the thread, and a couple of messages later I get invite. I don't know.
Something like that, yeah. That's
something happened.
You're very good at executive summaries, yeah. It's losing a lot of the detail here, though, but it's essentially a timeline, yeah.
Yeah, but yeah. So, it's funny thing. I don't know how this kind of spans maybe a bit, because in my Clojure journey, I was working in another Finnish consultancy, Solita, and we had a telecom customer, like one third biggest telecom in Finland, and we were doing this fancy new analytics stuff.
Are there any telecom companies apart from Nokia? I mean, I thought that was it.
Yeah, but there's there's Telia and Elisa and DNA, which you can go to the store and buy your subscription.
Okay.
Nokia makes the hardware and other stuff, but then you have these companies who make the cell phone subscriptions and
right.
So they kind of operate the network. They run the stuff that I don't know which one's hardware they actually use, but yeah, anyway. So but this circling kind of tying the ends of the rope or different ropes of this story. So I got to look into a lot of AWS stuff, and I was messing around with lambdas. This was 2016 is things, and I guess it was maybe 2016 that I watched the talk on Clojure Cons that Christoph Grond was giving with some other guy whose name I forget. Sorry. On what he was working at that time. and okay, I might remember this wrong, but he was working with this Apache Spark, so this kind of batch streaming, batching process, kind of MapReduce kind of thing, and he was making a library to use Clojure with Apache Spark in a nice way, and how like Spark is written in Scala, and it has a kind of shell, like Spark shell thing, so you can kind of start to shell a kind of REPL, and then type code in there, and it would compile it, send the bytecode to the cluster and to the worker nodes. But there were some Clojure libraries around Spark, but they kind of required you to ahead of time compile stuff. So you kind of lost the REPL there. But Christoph was working on a library called PowderKeg.
Yes.
Yeah. So you could like start the REPL, and it captured the bytecode, and it used this same mechanism that Spark had to basically add a char to the class path of the worker nodes. So I was like, we were also like looking into data stuff and on that project, and I was like, hey, like we have to like look into this. But so start of 2017, I was going to parental leave. I had my like second born, and so I kind of left the project. I came back after 3 months, but so during that time I was kind of
the Americans are all thinking, what is this guy? What is going on here? You know, what do you mean? We're not back after like 15 minutes of parental leave. Anyway, epic times, yeah. So you came back.
Yeah. Actually, like the current project that I'm in, my colleague also left for parental leave, and he's maybe coming back in August too. and that project is for a client that's in the States, so.
That's really trolling. Okay, yeah.
Yeah, but so yeah, neat time. So I kind of like just bumped a bit and tried to like contribute to the library. Spark was going through upgrade of 1.5 to 2.x something, and they had some like binary incompatibilities actually. Like,
God damn it.
Yeah, Scala. I don't know.
It's Scala. What you can do, yeah.
But well, actually, not actually the Scala kind of compiler thing, but other things. But yeah. So anyway, I remember that the talk that Christoph gave, he like said at the end of the talk that he had some ideas for Lambda, and I was like, Then I started like contributing, and he contacted me, and then like I guess I forget, but maybe it was him who kind of suggested that, hey, there were some ideas on Lambda. Yeah, I watched your talk. I know. let's work on this, and we submitted a talk proposal to Clojure Tray, and it went in, and then like some amount of talk-driven development followed.
Yeah.
So, but
this is common in academia, by the way. Like you supply the abstract, and then basically it gets accepted, and you have 6 months to actually figure out whether the abstract can work.
That's how industry works as well, as far as I'm concerned. I make a proposal and I get funding for it, backing for it. Then I spend the next 6 months actually seeing if it can work.
Yeah, very similar. Like you have to get VC funding, and you have this. So like this. Yeah. Okay. I don't know. And another story. Maybe this winds back into like what Ray was asking. But I remember my that this Ekahau times we were doing this hardware to like track with Wi-Fi stuff, and the CEO of the company was going to investors, and the device was quite kind of small, and they had like first 3D prints of the device, and they were like, but the like of the box, and but it didn't have any innards, it didn't have the chipsets and like stuff inside. So he like he told the story that he went to the investors, and when going from the hotel, he put some soap like from the hotel into the box so that it would wait a bit, so it would look more real. so and then you try to get the funding for the company.
Did they wash their hands of him?
I don't remember, but it was good times at the company, so maybe it worked. So yeah, so I don't know. So we did this 2017. I got to give a talk with Christoph in Clojure, and it was on this port key project. And
right.
So idea was that you had REPL and you defined the function there, and then we captured the bytecode and deployed it into Lambda with the JVM runtime. And while you did this, you had this function kind of called mount. So you got to define that I have in my REPL I have a function and it takes these arguments, and the mount function took a URL template and you mapped the URL parameters to the function arguments. And when you did the mount, it created an API gateway route into AWS. And then the idea was that you could fast way to deploy a Lambda from your REPL, and then you get it running. And so it's super fast way to kind of deploy. But that was then. Other interesting stuff spun out of that. I guess Christoph was looking at the Clojure code that I was writing to interact with the Java AWS Java library to create this AWS API and Lambda, and I don't know. There's lots of REST APIs to configure stuff in AWS, and this could be more generic, and then so we spun out this AWS SDK library, which generated clients. It did basically the same thing that AWS API, the Cognitec library, does. But and at the same year, the AWS API library comes out, and I was relieved that there was a lot of stuff to do on that era, but then it kind of turns out that this other company has been making this 5 years and they put it out, and anyway, but yeah, so I don't know, I've been then I went to other projects and actually kind of switched company, but I've been kind of looking at this. There's something that kind of stuck with me with the idea of this running Clojure in the Lambda environment, and I guess Ray had a kind of idea that there's this Holy Lambda thing, this made by this Carol. I probably butcher his name if I try to, but this so which kind of has tooling around making AWS Lambdas with native image compilation, because you cannot remember that. So how AWS Lambda kind of works is that, or I don't know, I'm not in the team, so I don't know. I just what it looks outside. But there's but I don't know. They have resources in their compute data centers, and then you define this Lambda and it starts a process. And I kind of in the CGI sense of era, when you were having your Apache and PHP, and it just send the file there, and then it starts the process to run the script, and then the script runs and exits, and yay, you have your HTML on your browser. So there's lots of options doing this Lambda stuff. You could do JVM Clojure and use the built-in runtime that AWS has. If you are if the startup, because JVM startup isn't that fast, then this all the Graal VM native image stuff kind of came along, and like Orkdude is doing great stuff with the Babaska thing, and so with Holy Lambda you have there's a custom runtime, like early days Lambda didn't, it supported like I guess really early on supported Java quite early. I don't
so.
Maybe Node.js maybe, but Java was like there quite early. But so
I think it was one of the earliest ones, because remember me and Wouter actually worked together at the time that Lambdas came out.
Yeah.
And I think it was around about, let's say, the August or the September it came out, and I think we all got excited about it, and I think we did some kind of like proof of concept around Christmas time.
Yeah.
And then we did a project with it the next year because it was pretty successful, And Java was definitely there from the start. I'm sure of it.
I'm pretty sure we did some in Java and then some in Node.js. I kind of remember writing some Node.js code for it, but fairly certain it did Java back then. This was beta, right? Like it was pre-GA.
Yeah. So like they had this like only write business code kind of thing, but but I kind of think that like targeting Java would be like, hey, there's the business code.
Yeah.
but yeah. So okay, if you want to do Clojure on the Lambda, you could do the JVM Clojure, but it didn't start that fast. So you had other option could be just to abandon the JVM also totally and go Node.js. And maybe it's just because I don't know, this old Java guy and like.
Well, I've got to tell you that like you talked about Borkdude earlier on. He has this Babashka that does it, but he also has another tool, NBB, and NBB, which is a kind of JavaScript implementation essentially of like Clojure script, but it uses this Psi interpreter, and then NBB you can deploy that to Lambdas. And again, I think what you're looking for, you're just looking for a very, very quick startup, because I think people have done all these studies that say that performance is kind of evens out if you've got like, because the thing that you kind of missed out about the Lambdas is that unlike the CGI thing, there is something called a warm start and a cold start. So maybe just pick that one up.
Yeah. This NBB thing. I remember when it was called TBD, to be done. so like I was, there's also like one trail of thought there. Like I for some reason I was dabbling in like running Clojure script on top of Node because of writing this. There's this front end testing tool called Cypress, and so I tried writing this. Well, I was reading their docs, and like my colleagues were like also like that. It was a kind of a hype that this is the thing. But how do you do Clojure on this Cypress? And they even in the docs they had this like, okay, you have this preprocessor, and you could do a Clojure script preprocessor. It reads on their docs like hey, who put Clojure script here? and like, but is there any Clojure script thing? Well, not really. Then I was dabbling in this area, and I don't know, writing a proof of concept thing that kind of Tommy at our company like looked at, and now it's also in a couple of projects. So, I don't know, but I don't good stuff there. But I was kind of dabbling on that Shadow CLCS compilation and like running on top of Clojure script on top of Node, and somehow bumping into Borkdude. And I guess he got bumped by this let's do Psi on Node a couple of other times too. But that's my moment when I got like included in. He did a presentation like when like NBB was kind of out, and I was listed also in the like slides on contributing a little. But yeah, NBB is really great, and there's like a couple of people in Clojure like that being like looking into this Lambda stuff, and all, like NPB, the Node stuff also included, and it's good stuff. And I guess like Porkdude is working with this cherry thing, so there's like part of kind of you get to compile stuff, not always interpret. So that might be like a good way forward also. But I was still like wishing that it would be neat that there would be something for the JVM Clojure, so I wouldn't have to abandon the JVM. So
yes, definitely.
Yeah.
I think everything else as well. I mean, the truth of the matter is, I mean, Porkdude is epic, and we all know this, and the tools are really getting a lot of community support. But if you go to a large company and say, I want to use this like tool that's just hot off the shelf 6 months from this one guy, it's kind of like, it's okay for experimenting and stuff like that. But for like, if you're going to deploy it for business applications, and I have done that, so I'm not against that. But a lot of places you can't do it. I think in startups and very small companies, you get a lot more freedom and latitude to do that. But if you're in a kind of relatively large company, and you have to have some, like, let's say you have to have some process of getting your technology approved, it's more tricky. I'm not saying it's impossible, or and of course it should be possible, but I think a lot of people would quite like to be able to use the JVM lambdas, and I think it's not just because of like the JVM per se. It's because they've got some code they already use. They've got functions, they've got libraries, and they just want to put that, rather than putting, like, they want to have got a microservice now, they just want to split it out, some of those functions, and put them into lambdas because, it only runs once a day or something, that kind of stuff. So there's plenty of like ad hoc reasons why, Java Clojure, JVM Clojure should be a kind of first-class citizen on lambdas, I think.
Yeah.
Sorry, Martin.
I was going to just like echo the point where like you might just have a sizable investment in the ecosystem, like internal libraries, external libraries that you know how to use, patterns that you've applied that work well, or just like integration with existing things, right? Like there's a good client for this thing you have internally, and there's those things are valid. Yeah,
Kafka.
Yeah, for once. But and those things are immensely valuable. Like there's why you should not have to abandon them, because and that's for me, it's also like the telltale sign of good technology. It's like it can meet you in the middle, right? Like if the initial premise of a piece of technology is like you will have to rewrite your stack, that's probably not what you're looking for. You want gradual adoption. You want it to meet you where you are.
Although, like we said at the beginning, generally throw it all in a bin and write it in Clojure.
But like case in point, like why are we here, right? Like because Clojure meets you where you are, right? Like it allows you to bring all the Java ecosystem with you of libraries and drivers and like it actually it's the key selling point of why this Lisp and not another one is because it actually did make a very conscious effort to meet you where you are. You are on the JVM with all that infrastructure, so let's embrace that. And
that's annoying. That's annoyingly reasonable. Yeah.
See, I'll be banned from the next episode. It's fine.
Yeah, you need to get Vijay. You need to get more Vijay style. Be more polemic.
True. Yeah.
Anyway, sorry, Kimmo. We're going back to lambdas now. Come on.
Yeah. I still there's like one thought of like using another language. Maybe if you get in a big company into a project that's bought by a separate department. And
that's also true.
That kind of thing, and then work on the new stuff. It's, I don't know, I kind of experienced that. So
mergers and acquisitions help. Yeah, that's for sure.
That's true. Yeah, but and not to say that like there's lots of new people coming into the language, and it's not only people coming from Java background. There's lot of people coming that haven't actually been using the JVM at all. So it's really like good to be able to support other runtimes too. So
definitely.
Yeah. But yeah, so I don't know. There has to be this kind of fancy niche of trying to use the JVM in places. So yeah, I guess that the JVM test it's really dynamic. You can load in new code and well, Clojure has a good test repo and like well, the Lambda environment is kind of evil in that sense that it kind of fights you back that you have only processes that are only alive when an event is handled, and otherwise they are dormant. So like if you want to have a repo and you like hey, I want to repo this into this process and execute something. No, you have to send an event actually. So you can't have anything running on the background. So but yeah, I guess there was like a couple of stuff that I don't know, to look into that Slack thread. What actually did we talk about?
One thing I'd say about the other thing I'd say, there's a few bits of technology that have happened in Lambda land, let's say, that are interesting from a kind of deployment perspective and a REPL perspective.
Yeah.
We didn't really talk about this, but there was something that Amazon did before the thing we're going to talk about. It was called Lambda URLs, and that meant that you could basically deploy a Lambda and it would be given an address on the network and be given a kind of like API gateway by default. So that makes it like super easy to like establish a Lambda and establish a network connection to it. So that's really nice in terms of like just workflow perspectives. So if you just want to test out one function, you can just do that without any of this kind of fuss or muss in front of like, because if you want to use API gateways, then it's another bit of tech you've got to learn, another bit of deployment you've got to do. And, I don't know, I really, I've got a kind of, I don't know, I get API gateways kind of like useful, but it's, God damn it, it's hard to work with. So this Lambda URL thing is really nice in terms of like informally testing out your code in Lambdas. It's really good. You can just deploy it and you don't have to worry about all the kind of like, all the gateway stuff that is possible, And then there's this other stuff, the snap start stuff that we started to talk about.
Yeah, true. Yeah, and
so maybe you can explain a little bit about snap start and Firecracker and all these kind of things, because I think it's fair to say that we do know how Lambdas run, not perfectly, but we know that there's certain substrates in place because the Amazon people tell us, so it's not a secret,
Yeah, so I don't know, maybe they have two pizza or what's the kind of theme, and they build the service that has a like HTTP API. Then there's another pizza team who makes the API gateway, this kind of proxy thing. And I guess I don't know, maybe they with the function URL, maybe there's also pizza slice coming from the API guys that we can do this function URL for you, like
yeah.
but yeah, actually this Lambda stuff, because the current project that I'm working in is we had lots of serverless stuff going on there, and there's a bit of NLP machine learning thing. The kind of odd thing there is that the application is really infrequently used. So and like most heavily used at end of quarter. So kind of annoying that there's this like activity times and then dormant time, but this kind of Lambda thing kind of fits there. But and maybe it's the way currently we have the infrastructure set up is that there's like different AWS account per client, so it's really separated. So I got to so we were working on Lambda stuff there, and we did a kind of proof of concept first, which was mostly like talking from the front end directly to like DynamoDB and so on. But then we realized that we have to, like, having an API in the middle is actually a good thing. So, like options for like abandon JVM or go Node. I don't know. And then like, well, okay, if we go JVM, then well, there might be this startup stuff. Maybe that would have not been such a big thing even, but so I put in this holy Lambda thing. Then we have native image there for the startup. But like, yeah, the snap start, which came.
But I think the Holy Lambda, if I'm not wrong, uses Docker.
Well, yeah. So it has this custom runtime. So in the Lambda thing, they have these built-in runtimes where you can, like, with the Java runtime, for example, just put jar and implement an interface, and the runtime looks up a class that you give by name, and it has to implement the interface and invokes the interface. But the custom runtime is such that you have a process that pulls events from localhost from this specific kind of port, and the Holy Lambda has its own runtime. And
right.
That's why, and that runtime is then native image compiled. And
that's right.
Yeah,
it's not
at
Docker,
the end, at the end you have just your ring handler kind of, and you like close a ring handler, and you implement your API in that. But like, I guess it was in December last year, 2022, AWS came out with this Lambda snap start, and specifically, I guess it's currently only for the Java runtime.
Yes.
But turns out that how they run, that the processes that they run, they use this Linux hypervisor, this KVM, kernel virtual machine, and there's this firecracker thing, which I guess is some kind of front end to the KVM thing that they virtual machine manager thing. And
I think they call it a micro virtual machine manager, don't they?
Yeah, something like that. So that they like this is also something that I like bumped into long time ago when I was studying in university, is that what if you take a process and what if you freeze it? You save the memory and everything that the process is running, move it to another computer later time and thaw it. And it's not stuff start is same thing, but they when you deploy this JVM Lambda, you if you make a published version out of it, it's like currently kind of tied to the kind of publishing thing. Then they start the process, and then they freeze it, and it's actually like when you do it, if you go and look at CloudWatch logs, you see that they do it in like several regions, like they do several snapshots, like when that happens.
Right, yeah.
So, the thing why they do this snapshot is that resuming the snapshot is fast. So, like we had this in this like application. Well, this is like back of the napkin kind of stats, but there's a like ring API with Rated and Muuntaja and all the other metacin libraries and stuff, and it so it kind of took in the order of 5 to 8 seconds the cold start to start, but with that snap start you're like, well, in an unoptimized way in the ballpark of 500 milliseconds. And so like I went this effort of like putting native image compilation. There were a couple of tricky things on like getting, say, Clojure the body library, which has this bouncy castle kind of crypto things to kind of actually work with that. and then this snapshot like comes along and you don't have to do this anymore. So that was so that you didn't have to abandon the JVM. You could still be writing Lambda with JVM Clojure, and you you still have the opportunity for it to start fast because of this underlying kind of technology change.
Yeah, I think it's an amazing stuff. It's just like the virtual machine images used to get, or whatever. Pre-Docker, people used to make a virtual machine and then send it around, but it was very heavyweight. But like you say, now what they do is they start up this process at a certain entry point, freeze it, and then they'll just rehydrate it on demand. And their argument is that all you do is just read it from the disk and just start the process running. Then it's super, super, super fast.
But if I have to wager a guess here, I'm fairly certain it's essentially a VM snapshot, because basically your Lambda is an actual VM, right? So
it is a VM snapshot, yeah, and that's what Firecracker runs these. They're called micro VMs, but the idea is that at the end of the day, this Lambda is a virtual machine.
Yeah.
So we don't know, like Kimmo says, we don't know how it produces this machine exactly. What the mechanism is to exactly produce this machine, but it's some kind of like virtual. They're using some kind of virtualization technology to make it happen.
But I think most likely why it only works on the built-in one is because, like you said, you have to create your own class, and then like they will call the method on the class, which gets you the event, but that gives them like super low level access, because they can basically boot the VM, and they know also inside of the JVM then, like up until what point it needs to run before their code makes the method call to the thing you've implemented, right? Which gives them like this real line of like, this is where we snapshot, right? Like the code is most likely like just before we call your method handler, we're calling snapshot on the runtime underneath, and then you get
that's true. That's true. But remember, Java has an entry point called main. So there are already kind of mechanisms used in Java for this. So there are plenty of other technologies that can kind of take advantage of this. Like I think what you're saying is there's a sort of functional contract in the Lambda, which is definitely true. But maybe Kimmo can explain. There are other JVM technologies which are looking at doing something very similar. There is even a standard proposal for it, if I remember rightly.
After still for this. So the Linux also has this checkpoint and restore in user space kind of thing. So so if you have a running process, it might be reading out of a socket. It might be reading a file. It might be doing all sorts of useful and crazy stuff. So and then the kernel comes up and hey, let's close this and let's turn the lights off and put you into sleep, and then you have hey, but I have this socket here and I'm reading this file, and so there's all sorts of state going on, and that is possibly kind of tricky. and turns out that there's this checkpoint and if you go into the Lambda docs, they have you can implement there's a Java interface which you can implement, and which gets called when there's a checkpoint being made, and you have a method that gets called when the checkpoint is made, and then you can do other stuff like prepare for it. Maybe you could pull some machine learning image somewhere and initialize some stuff, and then when you wake up, you have it initialized and ready for use, and you have and that interface has method that gets called after the restore. They have some limits. I guess the checkpoint version, you have your maximum 15-minute runtime at use, but the restore has to happen fast. So there's, I guess, I recall that there's 2 seconds runtime that within this runtime. You have to do your stuff. Otherwise, if you don't, then there's a execution error. So, but yeah. So now I'm like blanking out on the like other standard stuff. But yeah, anyway, this process hibernation thing and thawing, like that's just allowed to still go and use the JVM. So that's a nice thing.
I mean, I think the point is that there is a. I mean, maybe as we'll park that JVM standard for a minute, but the point is that it's actually quite a general solution. But I think what's interesting that we talked about in the library that you made is how to exploit this these hooks in the snap start thing to kind of rebuild the Lambda, the Clojure Lambda, so that you don't have to have this the cycle for kind of like redeployment is super smooth and super quick. Maybe talk through that a little bit, because I know that's pretty exciting, I think.
Yeah. Hopefully, like there won't be a letdown at the end. but yeah. So I was like, okay, hey, there's this snapshot, and what if you like have new code going on that we would have this checkpoint phase where you could like execute stuff. So you could have like a because there's because there's this other kind of thing. Lambda has this layer kind of thing that you can make some kind of shared layer and then have the application code. Yeah. So the idea that I had that let's only okay. So let's do it so that you could deploy your Lambda, the Clojure code, and for it to run, you have to ahead of time compile. But what if you wouldn't need to do that ahead of time compilation on your machine? Let the Lambda do it. So idea was that you only compile this minimal class that is the Java Lambda runtime works so that it loads a Java class. So what if you compile this Java class and not the whole application, and inside the Java class you do requiring resolve. So you load the Clojure code, and it's only at that time when you have to turn the Clojure code to bytecode, and you might have like, I don't know, some amount of Clojure code maybe running there, maybe, and doing this at the start of like event handling would be not so nice. But hey, let's put this into this checkpoint phase. So when
you've got 15 minutes, yeah.
So you got a CI that has 15 minutes of credits.
Yeah.
So let's try doing that. So I did this CLJ Lambda layered thing. But okay. So I kind of continued after that, also looking a bit further. But it kind of actually turns out that like the laptop that I have is it's kind of speedy. It's more speedy than the Lambda that I have. So why not use it to do some amount of the compilation too? So but the idea was still to kind of use the checkpoint phase for like great good do stuff on the cloud. Obviously, they also you for that, so it's not like a freelance. But but anyway, like open some kind of avenues of doing computation during the deployment in order to prepare your stuff so that when the event comes, then you're ready and and kind of tie it to the kind of development phase that you would like have a fast way of deploying stuff. Maybe this could be a segue to that another experiment that I did after that.
Yes.
Yeah. So like so this port key and with hacking with Christoph Grond and a kind of live Lambda from the REPL reloading thing. Like I guess like one idea left from that time was that, well, what if you put because every time when you deploy a new Lambda, it has to make a new process. So it has to kind of abandon the old process and start a new process. But what if you like would not do a deploy? You have a class loader in the JVM, and you could like go and load new code, possibly into the running program. So okay, let's do a setup so that so I did a library. What's the name? This CLJ Lambda site loader. So so you do this initial compilation. You initially compile AOT, compile your Clojure JVM code to bytecode, deploy a Lambda, but include into it a side loader thing that when enabled just goes and adds to the class path with a URL class loader a new archive. So you can do an arrangement so that you have your Lambda initially and then deploy it, and then you leave a watch running on the background. And when you do new Clojure code, when you first ahead of time compile the Clojure code to bytecode and send the archive to Lambda, you skip the Clojure source code. So you only put the bytecode there, and how Clojure compiler works that it looks at is there a bytecode for this like function, and if not, then it looks that is there a file for this where this stuff is contained in, and then it does the compilation. So the idea was that okay, let's do a side loader that watches that if there's any locally you start a watch that packages your Clojure code into a zip file, puts it into S3, and when the Lambda runs, then it goes to S3, looks at this specific object, and if it has changed, then loads it locally onto the class path, and then you have to write your event handler so that it's reloadable. And in the event handler, before running the event handler, we basically call require reload. So, so that's a kind of neat hack. But I haven't used this in production, but I don't know. I don't have others like not using it. But yeah.
I mean, to me, it sort of reminds me of like, people were sort of talking about the iPhone. Like if you're on the iPhone and you want to deploy something, then you have to sign it and you have to upload an artifact and get it all deployed. It has to go through a kind of check at the App Store. They get it signed off and then it's deployed onto the phones and it's in the app. It's in the App Store. And when Apple released this JavaScript core, a lot of people started saying, Maybe we can load code at runtime that doesn't require going through the Apple store, and it turns out that Apple are okay with this, providing you don't change the nature of the application. As long as you're just basically essentially bug fixing or just adding small features to the application, then they're okay with it. And this kind of reminds me of that for Lambdas, that you're avoiding paying all of that cost of the kind of deployment hassle and all this kind of stuff. And instead, you're just using a really nice trick, let's call it, to essentially load the code at runtime.
Yeah.
No one gets hurt,
True. Yeah, I remember React Native when it came out.
Same pitch.
I had a chance to do a React Native app, and I was almost doing that sideload stuff, but then didn't quite make it before it had a tight deadline when it had to come out. But yeah, I guess at the end of the day, it's Lambda and how AWS they make the environment, and they have their how you should use it. But then I was hey, there's this idea,
yes,
you gave me a computer, I could try using it this way.
but isn't it also a bit where, I mean, it's been a long time since I used Lambda, so maybe the ergonomics of it have changed, right? But what I still remember is that the dev cycle is kind of long, and the deployment process is kind of painful. There's quite a few, like you said, there's quite a few steps to it, and so it's cumbersome and it's slow, and especially during development, you want quick feedback. I mean, it's why the REPL is praised in every episode, right? It's the fast feedback is especially when I write the code very important. And with Lambda, I didn't have that at the time, right? Because the only way to sort of test it was to run it on their infrastructure, which meant you had to do a deploy, which best case scenario, I don't know. I don't want to put a number in it, but it was counted in minutes, right? Which is long enough to get you out of your flow. So I feel this is meant to scratch that itch, I guess, because you just package a zip and upload to S3, which goes as fast as your upload link can do, and then you fire off the event using curl, I suppose, or something similar. And and you test, which gets you way closer to how you would develop something similar just locally on your laptop, I guess. You have a REPL, you patch the function up, and you hit the same HTTP call, and you check whether the result is now what you want.
Yeah, I mean, Amazon has this for other languages, not for Java actually, but for other languages, it has this console. So you can go into the console and you can change your code and redeploy. And that's actually quite nice and quick, that one.
Okay.
And that's one of the things that Borkdu was trying to push for when he was doing NBB. And depending on the arrangements you make, if the NBB code is relatively light, you can edit it in the console, redeploy, and then you get what you're talking about, Wouter. It's super fast. You've got something, or you've made a mistake on some colon or some small thing, or some number is out of whack or whatever. So hey presto, now you can do the same kind of thing without all the bullshit of Amazon's console. Even you can be doing it from your let's just put in Vijay's little word here, Emacs or some other shit.
Exactly. I was going to say, but it doesn't have Emacs, the console. It's not Emacs.
Well, maybe we can paste in his question now, Kimmo.
Emacs or some other shit?
Yeah. So it's Emacs.
Oh fuck. Okay. Thank God we've got the interesting stuff out the way first. Then. Okay.
Yeah. Although, I don't know. So I had good friends at university, and they were all using Emacs. So I don't know. I went along. I had my years of Eclipse, and Java.
Okay. Oh well.
And I don't know. It was when I was coming back to Clojure. Then, there was Eclipse had a plugin. I forget the name. But it kind of died out. but
clockwork or something, wasn't it?
Yeah, counterclockwise.
Counterclockwise, yeah. Clockwork,
but, yeah. But I don't know. I guess I don't know. I then kind of went back to Emacs. So, and
the Eclipse startup time makes Emacs look fast, so it's
true.
It makes JVM Clojure and Lambdas look fast.
Yeah, exactly. So like if that's the alternative, like I can't blame you.
Yeah. But yeah, like this Lambda and development thing. I don't. Maybe it was Rich who said that not everything is awesome. So, so yeah, it's not that awesome. But I guess there's something to it to try to like. Okay, hey, maybe they are working on it and start and stuff, and kind of like could there be a way? So it's kind of enough of a lore to kind of look into.
Yeah.
That thing. Yeah.
No, I think you did a really great job there, Kimmo. Actually, honestly, I think it was. To me, it's sort of what it triggered in me was this feeling, and I've had conversations with other people as well, that this seems like and I think it's once the sort of scales fall from your eyes, you kind of realize that this is just the way we should be doing things. So before we go into like that, I think there are probably some things like you say about like open sockets and networks and like seeds for crypto functions. There are bits and pieces like this that there are sort of design aspects of the project when you're restarting things. There are some considerations that you have to care about because not all state is equal. Even though you've got yourself all your bytecode state and you've got yourself started up, if you're relying on like states like particular crypto seeds is a great example, then you've got to be super careful. But in general, if you're not doing anything like that, or if you can arrange for those things to be injected after this particular startup period, and usually you can, I think, then it's all good. So then the question comes as to why aren't we just doing this everywhere all the time for everything? Because then what's the point of Docker, basically? It's like because the whole point about Docker is that it's runtime that can be shipped everywhere and restarted, essentially. But it's kind of heavyweight for what it's doing. So now the interesting thing to me about this is that this firecracker thing that we haven't really talked in depth about too much, but it's in the background, is it's Amazon's like first big open source project, and it is this thing that creates these virtual machines, and then is able to restart them and stop them and manage them. And it's very lightweight, it's very secure, very fast, and it's completely open source. So even other cloud vendors can use it. Hint, hint.
Yeah.
I don't know what you're talking about.
Yeah, I don't know. Does Ray get any bonuses from AWS?
Well, I'm thinking about my friends in Exascale who might want to implement Lambdas.
Okay. Yeah.
No comment.
No, but the point is that I don't know if Firecracker will be the thing that Docker became. Docker seemed to be intent on trying to kill itself, but it's a sort of idea of being able to start up a small process and then just run it super quick from the beginning. This has general applicability. It's not just something which is appropriate to Lambdas or to small things. So yeah, I think it's generally interesting.
Yeah, there's like this Java and the startup time. There's this project Leiden that I don't know how to pronounce, but yeah, like generally it's you kind of you trade CPU cycles for storage. In that sense that it will, when that I guess there could be a say environmental aspect also kind of that when you're about to
let's not get into the environment, because you get all these Rust fuckwits who tell us that if you're not writing everything in Rust or C or whatever, then you're burning the planet and it's all your fault. It's like, fuck off. Talk to Exxon and BP first. Yeah. Come to me later. Jesus Christ. Okay. Sorry.
Yeah. Yeah.
Anyway, Walter, you were going to interrupt.
Well, no, really. Like, just think about. Well, first, just wanted to say that something we've been experimenting with last 2 weeks at work is running VMs in Docker containers for hashtag reasons.
Okay.
But so it can be done. There's actually some benefit to it, but no. What I like about it is it's this thing where latency matters, right? Like immediacy, latency, like for feedback loops and things like that. And generally speaking, so like slow startup times, like they kill latency. And it's a bit the same. Like if you do like full fat VMs, let's call them like that, like startup times are slow and but it and I'm just ranting a bit here, right? Like general musings. This might not go anywhere, but I think that's also part of the brand of the podcast. So I'll just let it rip. But what I feel like in general, we don't really tend to optimize for that. Where like we optimize kind of for throughput, but and then often like that leads to batching, and like batching is very poor for latency. And then every once in a while, like latency gets really bad, and like some new tech will pop up which has better latency. Like you said, it was one of the prime reasons why Docker containers got pitched as like lightweight VMs, because startup time, right? Like startup time was about as fast as your program, and the runtime itself. I mean, there's some overhead to Docker, but like it's extremely minimal, and like at the end, it's just your kernel. But like startup time was a huge argument for it. And lots of different things, like all the work Borgdude's been doing, or most likely all the work around native image. Like there's so much engineering that's going on, but like the one thing like why people reach for it is startup time, because I can't build my CLI in Java/Clojure/JVM, and like if I do native image, which is like this huge chunk of like startup time, it's better. Like latency gets better. At the expense of throughput, because if you want to run a high volume web server, you're probably better off with like regular JVM over a native image. But just generally, it's kind of like I feel like often like lots of optimization gets put into throughput and other things, and we neglect latency. And then every once in a while, something new pops up, because at the end, like we like things to be immediate, you know.
I think there's also the sliding. So if I just before get Kimmo back in, I think there's also this like sliding scale in between like latency, throughput, and availability. And I think this last one, availability, is something which is what the sort of Lambda and Fargate and all these kind of things are playing with. This idea that actually you don't want these things to be on all the time. You don't want these things to be. You want them to be available all the time, but you don't want them to be consuming memory or space or electricity. You know, so if you can do things like really on demand, like at a network level, as soon as a packet comes in, you start your machine up, then that's really good, because that means you know no one's paying for anything at that point. You know, and it doesn't matter to a lot. And again, if you've got a very high throughput, very active website all the time, then you know your kind of design is horrible with these lambdas, because you know you end up spending a lot more money. And I think there's been a case in the last week or two where this has come back for Amazon themselves with Prime Video. You know, where they've reabsorbed their lambda kind of design into a monolith. But my point is that there's a kind of like there's a sort of 3-dimensional space here that we need to play with. You know.
Through like the I don't know where this GraalVM like currently is, but like it also has this like throughput problem that like if you run long time, you'll probably get better results if you would be on hotspot. And
it's not true.
Yeah, and I guess so. I don't know how they do the like billing, how like who like figures out how much users should pay from Lambda, but like if you like take a Lambda that would be like always on, and compared to EC2, the Lambda price is higher. But so like that there is this but like then I was listening to another podcast recently. This
no,
we don't mention it. Don't mention it. Don't mention it. Whatever it is, we're like Elon Musk's Twitter. You know, we don't like external links. You know, it's like freedom of speech is okay, but not that much. You know, come on, Jesus.
Yeah, true. So you can cut out the signal and thread name. So, anyway.
No, but who was it really? It's we don't mind.
I don't. This signals and threads Chain Street.
Okay, Chain Street. Yeah,
but
people.
Yeah. There's lots of OCaml in that talk. But yeah, they were like going through this garbage collection stuff, memory management things. But like that if you do reference counting. Garbage collections, it might be kind of snappy on like coming back on the reservations and freeing up, but if you do it, there might be like cases when just doing it in the background in batches is actually better. So it's like it's not everything is on the same shape, but yeah, this trading CPU for disk, like for the startup speed, that if you like would have a way to like do initializations of say I don't know if I guess the JVM and they are like with the project lading and so on, like let's try building something into the language too, that you could do work before you execute, and then while you are executing, then you get to apply this throughput friendly ways, but you could still have a way to like for the first thing that runs, like execute it in a fast way. And I guess there might be like when you run it locally on your laptop, it might be different than like when you run it in your data center. I guess in the like data center environment is, well, it's more closed. So, but on your laptop, I don't know, you might have, I don't know, cats running around, or so it might, the environments differ, so it might be a bit complicated to get the same experience, exactly same, working both environments. Yeah,
there's this nagging thing in my head, because I know there's a project that did exactly what you're saying here, and I used it. I can't find the name, but where you would start up, and then in runtime code, you would basically could make a call and say, like, take a memory snapshot right now, which it would write down. And
that's
then,
the crack thing.
Is it? I didn't. Well, most likely the pattern. And then you could start up another invocation and like reuse the memory dump that you did before, and like therefore regain. But I didn't use crack. Like, it was not that. It was something else. But like in any case, like you said, like this trade-off between startup time and disk space, or even like optimizations, because you could, for example, like you could choose to run pieces of your workload, right, which would get, I don't know what, certain pieces of the runtime in a certain shape or state, and then you snapshot that. But for the last hour almost, I've been trying to think of the name. It's not coming. But I've used something like that.
Yeah, but I think it comes back to this point that I don't know. It's not. It's like, we know there's a few things that are hard in computing, and caching is one of them. And that's where you're trying. You're essentially caching bytecode here. Whether you're doing it through a compiler or whether you're doing it through a snapshot, it's actually the same thing. Whenever you compile anything, you've made some decisions that you're committing to, And so you're essentially, you're caching your decisions, if you like, in a program. But in the sort of reality of the programming world itself, or the programming itself, you're right, Wouter. I mean, half the time, these caches could be just brought up front, and then brought into sort of being made live. And we're seeing this in the sort of web world, aren't we, where you have this server-side rendering stuff occurring, where, they're saying, actually, in order to give like fast startup time for most of our customers, we'll render it on the client, we'll render it on the server, so they don't want a static website, which is all server-side rendering ahead of time. But they want, again, it's like mix and match situation where they can render the server-side stuff for that particular client, then let the client continue its operations. And I think, and there's all sorts of technology around that. And I think it's very interesting how we're constantly trying to trade this space over. I think there was the idea in the past, well, I've got a computer at the end of the network, it's a fast computer, either it's a laptop or a phone. So, they're both got fast CPUs on them these days. But then you start doing more and more and more in the JavaScript, and it becomes heavier and heavier and heavier. The network load becomes heavier. So it's not even, it becomes impossible to actually open this goddamn page in less than 10 seconds.
Yeah. So the next thing that we have to do is some kind of awesome checkpoint restore thing that we built up. Not for the for the client in a specific state, and then like the client comes on and like wakes up the zombie and then it runs.
Well, that's one of the things, by the way, it's one of the things that always, I know we're kind of joking about this, but one of the things I always like about Lisps in general, and one of the things I like about your side loader, is that essentially you're just shipping code. You're just shipping. All you're shipping is like, like words, text. You're putting it somewhere, and then you're letting it turn into bytecode later. Now, obviously, you've kind of played with it in your REPL. Let's say you're confident that it works before you save it to disk or ship it over there or rely on it. But it's very nice to be able to just be sending small bits of text around to be compiled at the right time. I think this is really nice. And that's even if you're not the perfect REPL environment, the idea of being able to send code somewhere as text, and then let the machinery take care of like the deployment and the compilation, those kind of stuff. This is a wonderful thing, in my opinion.
Yeah. It's the SAP, the PHP file kind of thing.
Yeah. We're back to PHP. But did you say ooh, or did you say ooh, nice?
Actually, I'm nice because like when you talk with people who came up or who, let's say, who were around during the early web, right? Me being one of them, like the joy of deploying PHP, like where it was essentially like I edit the file, I FTP it to the server, and it's done. Like the immediacy of it, like that tight feedback cycle is what I know. Quite a few people who like don't like PHP, but by God, they love the way the deployment flow went, and like how it got us all excited. Like I've got this new feature, it's right there. I just put the file. And like this gets super close to that, which I think is really, like it's why I really, really like it, because again, like the fast feedback cycle is what drives joy, and like at the end of the day, it gets
like,
the endorphins flowing. Like
Although, like I don't know, I've been this clunky Emacs user, but the VS Code people have this, remote stuff going on, and like that's. The feedback thing there.
You can actually edit it over. You can edit it on the server and just hit Control S and it's live. But that's like we sell it as a superpower, right? Like I can open my REPL on my server and like hot patch it,
Yeah, and like I don't know, just like even the the kind of machine learning stuff. So just kind of recent realization, this VS Code and Jupyter and stuff. Like if you get a machine that has a GPU, you don't want to maybe leave it running like, and then discover at the end of month, okay, what's on your bill? so there's like something to in this running stuff remotely and being able to load code and get the feedback fast and use the computers that are there, maybe not on your laptop. I don't know. If you have that kind of machine on your home, that might be also nice. But
but I think the main thing for me is that like you can use your own computer and you can use their computer, but you don't have to stop and go through this extra build step. Yes. That's the thing which I think tends to kill productivity. You know, it's like, oh, I'm going to deploy something now. You know, oh, I've got to stop. I've got to think about what my tool chain needs to do to deploy it out. And I've got to think about this extra step. And it's so annoying to me. It's so tedious. I mean, I get that it's sometimes necessary, but to me, it's sort of, it's a necessary because we haven't got these other bits of tooling in place, you know? Now, there may be some reasons around security and provenance and blah, 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 which, you know, I'm kind of like, I'm down with that. But at the same time, I want that to be forced upon us, let's say, rather than be an inherent part of our environment.
It's context, right? Like essentially, if I'm deploying software that needs to go to a fleet of 500 machines, like a bit of process is kind of worth it. You know, like you want some guardrails, and like that can take a while. But when I'm actually actively developing something, maybe you know, I don't need to go through the same guardrails, and so. So what I'm sort of it's if the technology makes you go through the same thing, then it's not accounting for context. And so I think, like you said, you're not running the side loader in production, but like it's totally fine for a dev environment to get your feedback cycle, and then maybe and you actually have a nice gradual route to something that, you know, will get the seal of approval from the enterprise security team, right? You're not excluding it, but like at least I get in the context where it's applicable, I get a nice dev.
But I'll just give you one more example of this though that Borkdude did. So shout out to Borkdude again. Is this Skittle, because Skittle is another tool where you can write your ClojureScript code this time, and you just save it to your files. And then you like git push it, or if you're working locally, you just save it to your files locally, and then you refresh your page, and you didn't do anything. There was no shadow CLJS compiler running in the background. There was no ClojureScript deploy step. You just save the file, you reload the page, and the program just works. This is nice. And again, you know, maybe it's for optimization reasons, for loading files, you know, for like you say, Wouter, if you're going to deploy it to the internet and you want it to have provenance, maybe you have to go through this process of condensing it and, you know, whatever these things are. Then okay, fine. But for just developing an idea, just to scratch something up, you know, it's super nice not to have a bunch of tooling, and it's especially good, I think, for beginners. You know, these sort of experiences, all the kind of bureaucracy is a sort of inhibitor to the beginner experience, I think. So if you can kind of like get rid of the bureaucracy and just do things, then everyone's happier, I think. And then you can introduce these doing of things, like you say, for a particular context, you know, for a particular reason, because enterprise needs it. And then, you know, you can argue about that. Well, that's negotiation, if you like, you know, or that is kind of, okay, it's something we have to do. But it's not built into the tooling. I think that's the important part that we want to talk about.
Or if it is built into the tooling, then the tooling should do all of it.
Yeah.
Yes, indeed. Yeah.
It's just like don't leave it halfway. Like I've got this like the same thing with code generation. It's like if you start to generate code, like it needs to cover all the cases and work all the time, because I don't want to think about it.
I guess you can kind of easily end up into like works on my machine.
Exactly.
Don't want to go through the hassle of deployment because it's slow and takes time. So like I was there was a trail of thought left from like this Lambda like annoying the deployment thing. Like kind of forgot to say that how in this current project that I'm working on, we just use Yeti locally, and we have like the ring handler there. And it's funny, I think, like people come into the project and they not realizing that this is running in Lambda, because it's kind of so magical that how it works. But yeah, like if there's a like long taking not so trivial compilation step that you have to go through because there are changes that you have to try out in the environment there. Then you don't do that, and then it's so it's like the kind of dev process also. There might be the like, can we use this in production in the corporate way? that too. But,
Right now, Kimmo, I've just looked at the clock here, and it's like we're without Vijay, we're going very long. We're going very Oh my God,
he's the timekeeper.
He's the timekeeper.
Yeah.
Oh Jesus. Yeah. So like we're gonna really be annoying the audience here, but fuck it. If they've listened this long, they can carry on for another 10 minutes. So one thing we like to talk about actually is. And there's a few like standard things we like to go through at least. It's like one part is, and I think we've covered it a little bit, but what kind of things are you really enjoying about Clojure in general? What kind of things can you say that where's the joy coming from Clojure from your perspective?
Well, like I don't know, maybe I'm too old, but well, not actually old, but
maybe I'll flip the question then, because we can then start with the misery and end with the joy. Give you a bit of chance to work up to the joy.
It's really nice that working in REPL and working with the like data and code, and when you write the code to match the data, like both ways kind of even out. So like if you are like trying to you have some data that is kind of awkward, your code will also look awkward. and somehow like when you get the kind of shape of the data right, then you get the like shape of the code also right, and it's just like I guess it's the like the REPL choice. That's the kind of good thing. But yeah, I guess the downsides. Sometimes you just don't know what's inside this map in here when you're looking at the piece of code. But odds are that there might be something wrong in the code then, that it's gotten too far away of the context of the data that you are working on. That is that if you need like like I used to think that there has to be types, because how else you kind of can find out if you change a low level module somewhere, that what are the ripple effects. But like there's if you are in the place where you really need like that kind of info, there might be chances that there's something else also wrong. But it might not be like because of you, it might be of reasons of the project and context. And
if your type ends up being in every other file of the project, maybe you have a design and encapsulation problem, right? I mean,
but I really like that heuristic though, Kimmo. I've heard sort of people talk about it in around about it in certain ways, but I've never heard it encapsulated so crisply. That if the shape of your data is right, the shape of your code will be right. So that's really, I like that. I like that a lot. I think this is the quote of the episode. Because it rings true to me. It really does ring true. So okay, just rounding it out then. So what's next then for Kimmo?
For me, I don't know. Summer holidays.
For you, yeah.
I'm sure he'll find another runtime to hack.
Summer holidays. Yeah, that sounds good. Yeah.
I don't know. I tend to like work on interesting things, and interesting things kind of tend to come my way.
Okay, so they come at you rather than
Yeah, like it is opportunity too. So, but there might be like a lot of legwork done before that when it arrives. But
yeah, nice.
But yeah.
Well, this has been really good. Thank you very much. I don't know if you've got any more questions for Kimmo, Wouter?
No, not at all. Like amazing conversation, and thanks for putting up with me. I mean, I'm new to this, like I very much am the person behind the scenes normally. So no, but it was amazing. Tons of great subjects, lovely ideas, amazing quote. Because like it stood out to me, like Ray said, if the if the shape of the data is right, the shape of the code is right as well. And I was also.
I didn't say that. He said that.
No. But like, when he said it, like it jumped out.
But my contribution.
It's super powerful. Thanks. And I was also thinking like that's most likely why, or at least a big chunk of why I enjoy writing Clojure, because effectively this is true. It doesn't really add any complexity beyond that. Right. Like if you get the shape of the data correct, your code will look elegant and like everything is in the right place. And I guess that's not true in Java generally, or at least not old school Java, right? Where like it adds a burden on top of it that and like you don't get to this equilibrium, maybe.
Yeah, I think if you want to end on a Hickey quote, it's like the only thing you can do with information is ruin it.
True.
Oh,
Yeah. All right. I'll channel my inner Vijay on that bombshell.
we got to put him in at the end on that one.
Yeah.
True.
Yeah. Thanks very much, Kimmo.
It's been
really good.
Yeah. Thank you. This was like. Really nice opportunity, and yeah, I feel glad to have been here. Yeah.
Thank you.
Thank you for listening to this episode of DefN. And the awesome vegetarian music or the track is Melon Hamburger by Pizzeri. And the show's audio is mixed by Wouter Dullert. I'm pretty sure I butchered his name. Maybe you should insert your own name here, Dullert.
Wouter.
If you'd like to support us, please do check out our Patreon page, and you can show your appreciation to all the hard work or the lack of hard work that we're doing. And you can also catch up with either Ray, with me for some unexplainable reason. You want to interact with us, then do check us out on Slack, Clojurian Slack or Clojureverse, or on Zulip, or just at us at DefN Podcast on Twitter. Enjoy your day and see you in the next episode. Thank you for listening, and thank you for tolerating this episode. Your patience is very much appreciated. So, Wouter and Ray took advantage of my absence and decided to destroy the reputation of low-quality content that I have worked hard to bring to DefN. And I apologize for that. Nevertheless, I promise to return in the next episode to bring back my bullshit quality that you all expect from this podcast. Until next time, stay safe.